Hello and welcome to the 28th episode of building a 2D game with Flutter. Today should be fun. We will continue integrating the gRPC server that we built as a spike into our actual game. So we will connect the client to the server. We already integrated a server here, and the server is basically just invoking a games update service, which at this point has a play method. And what we want to do for now is just to have the client basically call out to this play method and await basically a result and then know that now it's ready to join the game. So we are going to put that client into our gRPC folder. So we're going to have the client. We could call it client for now. Let's see. Over here we call it client as well, so that would make a lot of sense. So let's do that. So we have a client and a server, and the client is just a class base that we will instantiate. So it needs a channel to communicate to the server. And it needs and then we have a game updates client, and that is basically something that I think was generated. Yes, so we're going to need that. So let's just make sure that we have that in our proto file, if that's defined. Well, let's just try to see if it exists here. So this client channel comes from, let's see, comes from gRPC, and then we have the game updates. We have that. Okay, so let's just see where that came from. That basically was generated, and let's see if that has a specification in our proto. Actually, we'll keep the proto open on the left here, on the right, and let's close that. So we did not define one per se, but basically it was derived from the service which is called game updates, right? So then Dart or the library that generates the Dart files basically deduces a game updates service, which we have here, and a game updates client as well. So that's how that works. Naming conventions, I suppose. And then we'll have a future returning function called init. And again, the same thing like with the server, we'll take a list of args even though we don't use them yet. And basically what we have to do is create the client like this. So for now, we'll just put this all in here. So we get the channel opt. So we already went through all this. Actually, if you want to review this, I'm going to actually copy this code over. I don't want to necessarily repeat what we already did. This is we did when we did the spike, we basically wrote this code, and now we have it. So we can use it, and if you want to kind of see how we built it, I would think that's let's see what episodes that would be. As you can see, we have the website here, which has a playlist. So episode 22 would probably be interesting. 21, 22, and everything beyond that as well, probably, but there we focus more on the data types. So probably 21, 22 would be most interesting if you want to catch up on how we did this. So let's actually make this a little bigger so I have a little more space here. Okay. Now, so we init the client. So we have basically we just make a channel, right? And then we'll basically create the client with that channel. All right, so the game updates client is something, again, that was generated, and we need to give it a channel and some options, and then it will give us this client. Okay, that's pretty much all there is. Now, what we want to do, first of all, we want to be able to request to play, right? So what we want to get a playing client, and we get that by requesting play. So actually, what I'm going to do is I'm going to move this now into method. And I'm going to call it create client, right? Because that's what we do here, create client. And then we'll have another method that says basically request to play, and that one returns a response future. Okay, so requesting to play, and how we do this is basically we return client. So this is our updates client. So we might as well call that the client. We'll see. And we want to play, and we give it an empty message, right? Because we don't have to pass anything in right now. Later on, we might want to pass in like a certain level that maybe the player selected once we support that. So for now, we don't have to do any of that. So now basically what we do, we create the client, and then we request to play. So however, we want to make that actually a public method so we can await it in our main function. I guess we need to return future value. Yeah, I don't know why this has to be actually an async function. We are not awaiting anything in here, so this can probably be just no function. This one is the one where we have to await. So basically, for now, what we'll put this we put a main method in here just to basically test this before we put this into our game, right? Okay, so basically we're creating a client. We init the client, and then so that will give us the client. So right, and then we can say client dot play or request to play, and that one we have to await. And so then once we're done, we say print playing with, and then this should actually give us back a playing client, right? And then we can print that out here. Not sure what this will actually print out, but okay, so we got the playing client here. So probably don't need to keep track of that here. We'll see. So now we can just run this one and see what happens. Obviously right now it should have an error because there's no server running it. But we can fix that. Let's launch the server. So now we have a server running, and now we can try to start that client again. Okay, interesting. So we got an error, looks like in the server, possibly. And so cannot add to an unmodifiable list. So I wonder where that happened. So let's put a breakpoint here, and let's try that again with the debugger. So we are fine up to here, right? We have no error yet. Now if we step over this, that's when, okay, we want to step out of this. Let's just continue, and probably like it'll tell us where it happened. Okay, here we got an error. Break on receptions. So What's going on here? I wonder where we would add something to an unmodifiable list. I'm guessing this might happen on the server. So let's look at the server code. So let's actually move this guy over here so we can have that next to each other. And for now, we'll just stop all of it. So let's see, when we are playing, we get or create a current game. And I think that's probably where things are happening here. Game.clients.add. Oh, because we made this const, does that mean we cannot modify it? That might be it. So let's try that, and then we cannot make it final. Cannot make it final, and so basically what we'll do is we'll just take a list of clients here. So basically what we're looking at is if the parameter that we will pass is null, we will create a new list. Otherwise we'll, and I think it can still be final now, yeah. So basically we're saying that if clients is not set, right, we will create it, we give it a new list. Otherwise we use the one that. And so, yeah, it would have been nice to make that an optional variable, but it didn't work, obviously, so we found another way to do it. So let's launch the server again. And now launch the client, and now we should have no more problems, hopefully. Playing game, okay. So playing with game ID and client ID. So that's really nice. So that works. Okay, so we got the client now connecting to the server. So, and now what we're going to do, we're going to actually now listen to game updates. We will not yet, we won't yet like handle disconnection and reconnection, all this stuff, because that's for later. We already did this in the spike. So if you want to see how that is done already, you can watch one of these episodes I mentioned. That was probably the last 26, 25 roughly. So, but for now we won't worry about this yet. I just basically did that in order to ensure that we can actually handle that. So when we listen for game updates, this is how we implement it. So let's just put this method in here because we already did all this work. And so, okay, so client update might not exist anymore. We might have renamed that. So let's look now. So what we actually want is, okay, we don't have that implemented yet. So first of all, let's write our RPC method here. RPC. And we'll call it sync. And it's taking a stream of something and it returns a stream of something. Okay, so now what is it taking in? It's taking in a playing client, but not really. A playing client is just part of what it takes in. So what we actually need to give it also is the keys that were pressed, right? So, and we already said we represented those with the uint32, right? And we'll worry about the gestures later. So now we're going to have a playing client. We call it playing client update or something. And basically we'll give it the client, which will be a playing client. and that will tell us what game is the client in and what's his ID. And then we're going to have a uint32 that are the pressed keys of that client. And the client will only send this update when there are pressed keys or gestures, right? When there's no key pressed, nothing changes for the server, right? Because the server has already all the information to keep simulating the game. But whenever we change something on the client, then obviously we need to tell the server about it so the server can react to that. So that would be the plain client update. So that should be fine. So it's taking in a plain client update. Let's just call it event because this is a stream. It's a stream of events, right? So we have a plain client event, and what it returns is basically a game state event. So we don't have a game state yet. And why am I not calling it game model? Because it will be slightly different, which we'll see in a second. So we'll have a message called game state event. And one thing that's going to be in there, for instance, are like many packed players, right? So I think in this spike, we already figured out how to do many of something. Just looking through this here. Actually, what we did in the spike, and which I actually like, which we're going to actually do, is we had a field called, or a message type called player inputs, which had the pressed keys, which we can say actually, let's just say player inputs, and that those are player inputs. Okay, now let's look at. So the other thing is we need repeated, and so this will be a packed version, which we will unpack. So in the plain client, there's not going to be any packing going on here. This is already all ints. So there's nothing really we have to pack as far as I know. But here we basically have a packed game state event, which will have a packed player model, numerous players, right? And if you actually look at our game model, what do we actually need to send around? So we have one player right now, but obviously that will change to multiple players. And once we get there, we'll actually rip everything apart and kind of like have to redo part of this. But basically there will be multiple players, not just one. The stats model, that would be also, that would just be one most likely because we're only interested in our own stats, right? And then obviously the floor tiles and walls, right? They don't ever change. So there's really no point in keep sending those, right? What we'll do instead is we'll most likely include those with the first client when we send the plain client here. We'll include some way of, so I'm going to put to do here, send floor tiles and walls. So that would be enough for the client, right, of the plain player. It would be enough for it to update its state, right? To say, okay, I'm going to put the floor tiles here and the walls, you will never go away. And that's my game now, right? And then basically, and then we'll basically just send an end rows and end calls probably also doesn't change, right? So then basically what will happen is the player will build a model without these things. It will just basically, it will build some sort of a model with these things only, and then it will basically just update these every time. Right? So that means that the game state will not include the floor tiles and the walls because it doesn't make sense because they don't change, right? So what we also need to do here is put it to do is in floor tiles and walls plus end rows and calls, right? Because they are constant. We only need to send those once. Let's put those into, okay, whatever. Not important. So now we get the plain client sending back, and we get this game statement, except needs to be a packed one. And what we will do is we'll create, and for now we'll do this all in gRPC. So make a folder here, message types, right? So we will create a packed game state event. So, oh sorry, it will actually be a normal one. It won't be a packed one, so you have to actually name that. Game state event. And basically what that will be, if you look at the packed one here, it will have a list of packed player modes that it gets. So if you look at the game state, it will start looking very similar. Game most likely the event will also have a timestamp. Don't have to implement everything now, but just let's make it to do there. Possibly needs timestamp. But what we'll do is we actually separate this out. So there's a game state event, but this will be and that's where that will be in, because we might be including extra metadata with the event that are not going to be part of the actual data we're working with. And then also we don't have to rename name this packed, because it will most likely not be packed. Just the game state itself will be packed. So that means also this will be the game state event, and it will have a game state in it. Well, let's think about this. So we actually just need to pull out the game state, right? We don't really need, well, yeah, let's just unpack and unpack this one. So what we'll do, we create also a class called game state, and I purposely don't reuse the game model, because I just said the game model will actually have more things on there than the server sends us, right? The game model will combine the constant information like the walls and the tiles with whatever gets sent from the server, right? So the game model is going to be having all the information that the client needs to render and all these things, but the game state is only whatever the server is kind of sending. And we could call this server game state, but for now we leave it as is. And if you look at the game state, there's going to be a packed player model, multiple of those. So basically what we're going to have a player model which it basically has. And the player model we can pull from here. And so now we just need to basically implement pack and unpack here. So what that means is there also needs to be a pack game state, but we don't have that yet because we didn't run the regenerate script yet. So let's do that real quick. So we have scripts regenerate, and if you're not sure what that does, it's here, but we wrote this in the last episode. So it just basically regenerates our generated code here, generated code from the protos. So basically, where did we put it here? Right, all this stuff is regenerated whenever we need to regenerate that whenever we change our proto definition. Now, so what we can do now, we can pack it, which means we get a packed game state out of it, and we have to pack this. And we also will have a static method, or like a factory method, game state dot unpack, and we give it a packed game state, and we call that data, I think, everywhere. So a packed game state will have players, and so basically what we need to do is, and I think we already did that as well, so I'm going to take this from our spike. At least I think we already did something like that. Or maybe we didn't do a whole... We have a game state. Okay, so we have already some code there. So I'm just going to pull that over so we don't repeat ourselves. It's almost like, I really am honest when I say I didn't remember that we already did this like that, and I basically was about to write the exact same code. So that probably shows us that we are on the right track if we're trying to do the same thing twice. Now the players, game state of players. So when we pack them, well, they don't have the pack method yet. So that one we already implemented as well. So we will definitely not re-implement that. So I'm going to copy that over, and I will see if that actually will just work as is. So we have to go to our player model now. And we have to hope that... So what I don't like necessarily is that we're now starting to get all these references to gRPC even on the client side, but I mean that's how it's going to have to be, I guess. So player flags, we didn't implement player flags yet, so but we did in the spike. We just basically put that right on top, so I think we'll keep that right now, and we'll clean that up later. I just want to get something working for now. And if you remember, the player flags are just basically a way to convert a boolean to these, or multiple booleans to one 32-bit integer, right? And again, if you want to review that part, that would be most likely packing, like this is where we're packing doubles, this is where we're packing the tile position, and here's actually, so episode 26 would be the one that you want to watch if you kind of lost here. So we got the player flags, and now we should have everything here. Okay, cool. So the ID, oh yeah, so we're missing the ID of the player. The question is if we really need the ID on the player model. I'm actually not sure that we do. So because we can easily identify. So instead of, for instance, having a list of players, we could have actually a map of players. So so I think that's actually better. And I'm sorry for the noise outside. It seems there is a race going on. Not really, but sometimes one could think that. So we're going to have a map of int and player model instead of a list. And so when we pack them, we just basically have to iterate through the values. And then when we unpack them, so let's see that the player model actually includes an ID, and it does not. So, and the ID I want to be the first one. So what we'll do is UN32 ID. And so now what we can do is we assign the ID, we give it an ID. Now this code should be happy, except that we have two. So I guess I removed the two stringless output here. So we say ID, D, and obviously we only want one toString. Okay, so now here we have an ID that needs to be 1. And let's just regenerate our code real quick. Now our packed player model should have the ID. So now if we pack the player model, we need to make sure that we add the ID. So put that here. Well, there's nothing we have to do with the ID, so we can just d equals ID. And then when we unpack it, we basically, we get the player model. Okay, so we unpack it, we get the player model, and we have to set the ID from the unpacked, from the packed one. So we can say data.id, okay. And now when we are back in the game state, we can now say, when we pack it, we just pack it as always. When we unpack it, we'll basically say that the players, well, what we'll do, we'll iterate over the players to make this a little easier to follow. Okay, so what we'll do, first of all, we'll unpack this. Right, and now we have an ID, so then we say that the players dot set. Now let me clean this up because I might get confused because of that. Oh yeah, we need to first create the players. Create a map. And then we say players.set or put, or we can just say this, p.id equals the player model. Right? And then we can return the game state. So now we have a way to pack and unpack the game state. And then the game state event, well, we didn't put the game state in there yet, so we need to actually do that and regenerate. Pack game state. So we won't probably have an ID and timestamp here, but we'll get to that later. So this would be the game state. Now we have the pack game state, but we only have a game state event. Things are, the question is if you really need this class. So let's just not have it for now. And now let's regenerate. So now we get the game state event. So now we can basically, on the server, we can populate the game state event. So we're gonna go to our service. Now it's asking us for that extra function. Perfect. Okay. So basically what it needs to do is it needs to iterate through all the playing clients. So we do need to actually store them, right? For now, we'll make it a list. Let's do, yeah, let's all initialize it in the constructor where we're supposed to do it. So we make a list of playing clients. And we initialize it here. Okay, so we got our playing clients, and then basically on the in the stream we actually need to return a stream that we'll push into, and we already went through all that. So I'm going to look through most of the code we already have on the server. And as I said already multiple times now, if you are interested in how we did that, make sure to to look into previous methods episodes. So basically what we had here was we had a stream controller. Okay, so we need to close that. Yes, obviously we do. However, the service will live as long as the program does. But what we'll do, we'll just implement the dispose method here. And we'll just let's do perfect if game state, okay, and it's if it's not closed, right? So now it's happy there, and then we have a way to get the game state stream. So that's what we return from here, except it's a game state event stream, which also makes me think we should probably rename this. And also this. And then obviously we're no longer sending a packed game state. Instead we're sending game state events. All right. Let me make this a little bigger. All right. So we can see that these are events that we are broadcasting. That means we can broadcast them to multiple connected clients. And actually, I'm going to put this higher because I like to have the public methods over here. So what we can actually now do, we just return the game state event stream and we should be done. All right, cool. So what we'll have to do here, right? We call it, what do we call it? Player inputs, right? Right, so we need to do that. We will not do any, we not run any controller code here. What we'll do instead is to basically we'll have like a game loop that will and we basically have that in a total separate file. So we're gonna have I wonder where that would go in what folder. Message types. Let's just put it right here for now. And we say this is a Dart file and it's going to be the game loop. And the game loop will basically take that stream and it might even own the stream. But actually, you know what? It won't. We want the server to be in control, but we'll have something very similar in the game loop. So okay, so we put this in here, and it will not be game state events. It will actually be just game states. Right, and then also we have to have a dispose method here. And let's just copy that from where we did this basically, except we changed some naming here. Okay, and now obviously we have to make sure, so we have a game loop now in our service. So And all the things might move around, but I'm just trying to at least keep some sort of order. We're still trying to kind of get things working, but I want to get some order going here. So obviously the playing clients should actually be part of the game loop, right? Because the service doesn't know this. Doesn't have to know this, at least. Well, or maybe... Yeah, we'll see. Maybe the game loop mainly is interested in obviously the game state, right? So the game loop will need to be initialized with a game state. But it won't be final. And so basically inside the constructor, except there will be numerous game loops. So this is where it gets interesting, right? Yeah, so this is already, I don't want to think like too far ahead here. So obviously we'll need multiple game loops because we have also multiple games. So actually what we need really is a map of in the game loops. But actually a game, what's a game? Yeah, maybe the game loop really belongs there. So basically here, but actually, you know what? When we initialize a game, it will create a. It doesn't have. So the playing clients might be important. What are the playing clients? They don't have any information about that, so this is not part of the model. A game loop obviously needs to have game state in it. So what we might have is some initial game state that we're passing in. So just if we have some game state. And then basically we'll say the game loop from the game state. And we need to import this. No, I don't. I do want the package to be part of the import. Okay, so let's see how this looks. And from the game, we will basically expose the same stream we have in the game loop. Let's put this here. And that basically will be the same as the game loop. And then we need to be able to dispose and then we dispose the game loop. Okay. Okay, so now we got that cleaned up. So we got games, we got playing clients. I'm not sure why we necessarily need the playing clients, because when a playing client comes in, we create a game and we can basically manage them in here, right? So we add the playing clients here. We don't need to manage them separately as far as I know. So let's just get rid of this. Okay. Now maybe already overthinking this. I want to get to something that at least like to get some game event, but we might not be able to do that in this episode, in this hour. So when we create a game now, get or create current game. What does it want now? It wants some extra. It wants the game state. So what we'll do here, then we create a new game state. So this, by the way, doesn't make sense, right? Because we also have to check if the game already existed, but we'll do that later. So the game state would be some game state, and let's just see what it needs. It needs players. For now, let's just give that here. It's complaining because it wants players. But you know what we'll do? We won't require players. We just say it's like players equals list. We just create a new map for now. And then we'll have add player to that. So what's wrong here? Also, this can be private. And final. And so now what we can say here, we have a way of adding a player. Right? So now we got that figured out. Now we're gonna have a getter. Let's just call it enough players. And we'll say that you need at least 2 players, right? So if you say players.size length, what is it? Length. For now, we say that's true if we have enough, if we have at least 2. Okay, so we got the game state. We're creating a game. The game will have a game loop, and now in the game loop, that's actually where. So the game loop, it will basically start. Until we start, nothing happens because we're not ready. So when we are ready, we'll start the game loop, right? And so obviously there will be called from the game itself, right? So it will be a start, and there will be game loop.start. And what we can do though, we can ask our current game state. Where is it? I thought we have some sort of current game states. What happens? What's happening to this game state? Oh, we have the game loop start. So the game loop does have the game state. So it should basically figure out So basically what we're going to do is like, we're going to say this, we're going to call this try start. And then basically here, we don't have to return anything. So basically, once we add a player to our game, then we'll try to start the game or something like that. But we won't worry about those details yet. Let's see. So the game state now it doesn't have players yet. We need to do this like this. What's wrong here? Oh, because it's probably final. Don't have. Oh, so then. Or just say we create a game state. And then we'll add a player here. So. Okay, so that changed a little bit. Okay, so now basically, when we unpack, we just use our add function to add that player, and obviously now also on the server, whenever a new player joins, we can do that. So now we have our game, and we have multiple games. Each game has an ID. Each game has playing clients. I don't even know if we even need them in the future, but we'll keep it around for now. And basically then there's a game state here. And basically what we'll do we won't even have this. We need to map the game state to a game state event. But I don't think we actually need a separate stream for that. So let's just say the game root of game state, just verify that we're broadcasting there. Yes, we are broadcasting. So then what we can do is when a client wants to sync, we look at the game ID. Oh no, sorry, we need to listen to that, right? So that code we already have, and I will basically pull that out, change it a little bit. But basically we had already a consume client events function. We'll write the function now and we'll hook the stream up later. So basically, for now, actually what we need to do, we need to just do this, consume or process. Let's make it clear and say this is a playing client. And then this will be a playing client event. Okay. And then basically we say event.id. There should be a game ID or something. Nope. What? Okay, let's see. Why is this not? Let's look at our... Oh, the event has a client. And actually we need to do this. And just regenerate. There was a typo there. So the game has a client. So the event is a client. All right. And then basically the game then we're gonna assert for now. obviously there'll be some protection. We can't crash the server if this happens, but cannot find game with ID. Right, and then we have our game, and then we can say game dot game state. Well, actually, hold on. This game state event thing here. That is a little weird. It's a little complicated. We already made our life a little harder. Because basically these game state events, we already need to figure out, we need to get them for a specific ID. So we need to basically map. What we need to actually do is we need to map. Because this is what this function is. It maps a stream of client events to a stream of game set events. Right? So what we need to do, we need to take that event. So these are actually, it's an event stream. So let's just mark it as such. And then we need to say that return event stream.map and we just call it sync for now. And now we create that method. And that's now looking better. And that's pretty much what our thing already is. Except, here's a problem with this. Yeah, we can't just map. Yeah, we can't just map. No, that won't work. Because we need to push out more events, possibly, than we get from the client, right? The thing is, I don't know which event to listen to yet. Okay, so I think maybe we need to do this differently. I think maybe this won't work like this. Because, I mean, we're having an event that's coming in, but we don't know what event to return yet until we get the first client event. Our sync method is wrong. Yes. So we can do it this way, but our sync method needs to tell us what it needs to already give us one. It needs to give us the playing client already, because we need to know the game ID and the client ID, so we can right away figure out what the stream would be. I hope we can do this, by the way. Okay, let's see. Okay, let's see. gRPC take multiple arguments. Seems like it's not supported. Let's see if that works. If you just don't put a comment. Yeah, it doesn't work like that. So we need a sync request or something like that. And in there we'll have a stream. We have both these things. Don't tell me you can't have that. We can't have that. So we could have repeated or something like that. That would work. Hold on, maybe it will actually. Well, it already looked like it's not gonna work, but basically, event stream. Yeah, that won't work. It's not happy. That part is happy. Okay, so it almost seems like instead of having a bidirectional socket, we have two one-directional sockets. So basically what we could do is playing client, and we want to get game state stream or whatever. And we give it a client, and then we get game state events. And the main reason is because we don't want to have this flow where the client is sending an event and then we send a game state, then the client is sending an event, then we send the game state. We want to give it a game state right away, like a game state stream, right? And in order to do that, and we're running out of time, in order to do that, I think we need to change these signatures. I don't think there's a big problem here. I would hope that gRPC implementation actually kind of puts this together into one socket anyway, so that it doesn't open multiple sockets now. I would hope so. So it's probably just our implementation detail and probably doesn't hurt anything. But basically what we want to do is we will take a method and we call it, and we'll probably want to call it game states. Or actually we're going to call it subscribe game states. So then it would be called subscribe game states. And then we get a plain client. And if you think about it, that's almost the same as what play does, except play gives it back the plain client, which it needs to. So I think that's fine. So we get a client, then we subscribe to game states. And then there'll be another method that will be just RPC push or add playing client event. and there'll be stream, and that returns nothing. So what do we want to call this? So we have subscribe game states, right? We could call it on. It's probably nicer. Okay, cool. I will regenerate this now, and we'll stop here. I did not tag anything yet, so I'm going to do that now. And we'll check this in. I'm going to put a whip here in the middle of figuring out server client interface. And then we'll tag that with episode 28 end. Okay, so I will take a short break. I'll be back at 8:10 my time here. That's 10:10 Eastern. I hope you can join me, and we'll continue and we'll figure this out.